Okay, hi everyone. We're going to go ahead and go through the pre-calculus one final review, pre-calculus review one. And there's another video on YouTube about this to cover the full length. I'm just doing this for period 6. Okay, so we're going to convert from a radian to a degree. And if you remember, to change from a radian to a degree, we want to get rid of pi and swap it for 180. So we write 180 on top and pi on the bottom. And that's our ratio. Pi is 180. The 80s divide out. And then we're going to go ahead and say 5 times 180. No, too much work. And so I'm going to just go ahead and divide this by 2. I think this is going to be easier. That's going to be 90 and 2. 9 times 5 is 450 over 2. And then half of that is 225. Another way of doing this, you can always just replace the pi by 180 because pi is 180. And that'll give us our same answer when I divide and multiply. So there's a couple easy ones. This again just as a practice, remind us what we forgot. Now question number 2 is asking us coterminal. That's a key word here, coterminal. Now I gotta say this is like studying for the SATs. People practice for the SATs not just because of the content, but they want to remember the format of the test. Whenever I see this is what they're asking for. So they're not wasting. The angle between 0 and 2 pi in radians is coterminal. You automatically see the word coterminal and like, bam, I know what to do. You would save yourself, let's say 20 seconds per problem times 20 questions. That's a lot of time. Okay. Anyways, so let's go ahead and talk about this. We want to see coterminal. Okay, so where does this fall on the unit circle between 0 and 2 pi? 39 over 8. That's really big. So let's go ahead and divide it. That's going to be 4 remainder 7 over 8 pi. Okay. Now, here's something that we know. Every 2 pi, we reset. What I mean is on the unit circle, every time I go 2 pi, we start all over. So if I go 2 pi and then I go 4 pi, we start all over. And so coterminal is at 7 pi over 8. 7 pi over 8. Because we almost made it to a full pi, but we're a little bit short. So the angle here is 7 pi over 8. Okay. Now I'm going to make sure that we get these right. I'm going to go ahead and turn on the answers. Show me the answers. Oh, that looks ugly. So what happens, what they wrote this in pi. And if you take a calculator to it, you'll see that 7 pi over 8 is going to be 2.78. Okay, so when you write 7 pi over 8, you end up with that. Another way of doing this is just subtracting 2 pi. You say 39 over 8 pi minus 2 pi. Now, to change 2 pi to have a common denominator, that's really 16 pi over 8. So if you minus 16, we end up with 23 pi over 8. And then we subtract 16. Hey, that's still too big. We're going to subtract 16 again, minus 16 pi over 8. And then we end up with 7 pi over 8. And that's in my first 2 pi circle. That's another way of doing it. Now our next question is converting 60 degrees to radians. Okay, so if I have 60 degrees and I want radians, I want my pi version. We write pi on top and 180 on bottom. Divide out. Pi over 3. And you might have known that already. Angle 60 degrees in radians is pi over 3. Okay. An angle at standard position, what in the world, 651, is coterminal between 0 and 360, okay? So how do I get from 651 to something in my unit circle? Well, if I just go 360, and if I keep going, where would 361 be? Sorry, 651. So we just say 651 minus 360 ends up with, let me write it a different way so you can see it. 5 and 360. That's going to be a borrow 1. That's, oh, sorry, no, that's not right. I'm going to borrow 1. Why would I borrow 1? It's just going to be 1. 15 borrow 1 is 5. And that's going to be 29. Okay, so it's going to be angle 291, and yes, that does fit between 0 and 360. They are coterminal. Coterminal. These are coterminal. Okay, let's go ahead and move on. If cosine theta is 2 over 5 in quadrant 4. So these types of questions is, if you try doing this on a calculator, sure, you can do it. But that's not the goal of these types of questions. These questions are to set up the problems not using calculator. And if you give me some decimal answer, I know you use the calculator. So if I do cosine of theta, darn it, is equal to 2 over 5. Let's draw the triangle. They told us quadrant 4, so here's quadrant 4 down here. I know cosine is adjacent over hypotenuse, right? This is adjacent over hypotenuse. They want me to find sine. Fine, the sine of the triangle. Sine is opposite over hypotenuse. Well, we know the hypotenuse is 5. That's already that's 5, right? Now, what's the opposite? To find the third side of this right triangle, we need to use Pythagorean's theorem. Yes, 2 squared plus b squared is equal to 5 squared. That's 4 plus b squared is equal to 25. Minus 4 to both sides. 25 minus 4 is 21. B squared is equal to 21. B is equal to the square root of 21. Square root of 21. Now, also in quadrant 4, since this is going down, the square root of 21 is negative. So I'm looking at sine. Sine is opposite, which is negative square root of 21 over 5. And that's how they got that answer. How much time did it take me to do that problem? A minute and a half. Okay, if I knew what I was doing. But if I went and tried to run into my notes to try to take a look at what's going on, I'm not going to have enough time. Now, the cool thing is that once I submit this question, let's say, I wrote square root of 21 over 5. So I'm going to go ahead and write it. Darn it. If I write negative square root of 21 divided by, divided by 5, okay, enter. Remember, we can always submit the question and they'll tell us we got it right or wrong. In this case, told us we got it wrong. Why? I don't know why. Did I say 21? What are these? I forgot. Oh wait, so that was the wrong problem. Ha. This one over here. Darn it, this is all being recorded. Negative square root of 21 divided by 5. If I hit submit question, oh my gosh, you have not changed. Okay, so you can also up here, remember, you can click similar question. If you want to practice this again, you can click similar question, then it'll give you another question like it. And that's important because you guys want to be able to practice these skills. These skills are on the SATs, these types of questions, because they are from the geometry portion. And we will be using this in calculus. All right, let's go ahead and move on to my next question. I just wanted to spend that time to show you guys the get similar question button. Okay, let's do this next one. Now, they told us the angle is negative 5 pi over 6. Now, the cool thing is that we know where 5 pi over 6 is. That's a 30-degree angle, right? Pi over 6 is 30 degrees. And negative, so we're going to be right here. We're going to be right before 6 over 6. And since we know it's a 30-degree angle, we know it's 1, 2, square root of 3. And you might have forgotten this, both of them being negative in quadrant 3, because we went left and down. Now, since we drew the triangle, we have everything we need. So how do you show work for this? You got to show me this triangle. If you don't show me the triangle, how, as a miracle, are you coming up with these crazy numbers? Then I know you're cheating. And I'm going to have to fail you. Now, who wants to have that conversation with your family? So secant is hypotenuse over adjacent. Now look here. What's hypotenuse? Hypotenuse is 2. Adjacent and opposite. Hypotenuse is 2 over square root of 3, negative. And we don't like square roots on the bottom, so we say we move it to the top by multiplying by a square root on the bottom and on top. So it's negative 2 square root of 3 over 3, which is our answer here. Cosecant. Cosecant is hypotenuse over adjacent. Let's take a look at that. Hypotenuse is 2 and adjacent is negative 1. Say hypotenuse is 2 whoops, sorry, opposite. Oh my gosh, opposite. I was saying thing cosine. Cosecant is opposite because it's a reciprocal of sine. That's going to be negative 2. Tangent. Tangent is opposite over adjacent. So it's negative 1 over square root of 3. Negative. Oh, they're both negative. It's positive. And we don't like the square root on bottom, so we multiply to the bottom and the top. Negative square root of 3 over negative. Oh, that's a positive we said already. Over 3. So you can see how fast I'm doing these questions because I understand what's going on. But if I didn't and I had to go fish through my notebook, of course I'm not going to have enough time. Okay, same idea here. They're going to ask you to draw the angle. The angle is 5 pi over 4. Let's go ahead and draw 5 pi over 4. Pi over 4 is 45 degrees. So we know there's 1, 145, 245, 345, 445, 545, right? We're 1 over, we're 1 over 4 over 4. That's 5 pi over 4. Oh my goodness. This is a negative angle, so I wasn't paying attention to that. So we're going the other way. 1, 2, 3, 4, 5. We're going to be up here because we went in the negative direction. And since it's a 45 degree angle, because it's pi over 4, it's 1 square root of 2. Careful, we went left, so that's negative. So all these little nuances that we haven't seen in a while. Now the sine is opposite over hypotenuse. So sine is 1 over square root of 2. They want you to rewrite it as square root of 2 over 2. Cosine is negative 1 over square root of 2. Rewriting as negative square root of 2 over 2. Okay, so I know we haven't done these in a while. That's why I'm spending a little more time on the first couple of them. But if you want, I can jump to the law of sines and law of cosines also, okay? So I'm going to skip these guys here. We just did it. Okay, this one's a little tough. They gave us an angle, and they want us to find the other angle, okay? So if I give you sine of the function, sine is 4 pi over 3. That's over here because we were over 3 pi over 3. Now we're 4 pi over 3. Okay, and this triangle is a 60 degree angle, so it's 1, 2 square root of 3. Negative. So where else would we have a sine with the same answer? Well, sine is negative square root of 3 over 2. So when else would sine be negative? In quadrants 1, 2, 3, or 4. Remember, all students take calculus. So we're positive in quadrants 1 and 2, but negative in quadrants 3 and 4. So our next one is going to be actually over here. So what's the angle? It's going to be 5 pi over 3. 1, 2, 3, 4, 5. 5 pi over 3 will give me the same answer, square root of 3 over 2. And this is, remember when we talked about drawing two different triangles? And that's our second triangle for sine. If this was cosine, our second triangle would be over here. And that's going to be 2 pi over 3. Okay. I'm going to jump to a triangle. Let's jump to solving triangles here. A is 6. Capital A is 45. And the trick here is that, hey, this is a right triangle, so 90. If this is 45, we know this guy over here is 45. Yeah. And since it's a 45, 45, 90, we know the legs are always the same, and the hypotenuse is always square root of 2. So we have these special triangles of 36, 90, and 45. 45, so make sure you do know those still. This one over here is not a nice 36 and 90 triangle. Find the unknown values of the graph. Sure. Now, let me ask you, would we use law of sines, law of cosines? You guys remember the difference between law of sines and cosines? Law of sines had a angle side pair. Do we have an angle side pair? Angle side pair. This is law of sines. I can use law of sines to solve for this. Or since this is actually a right angle, I can use sine, cosine, tangent. We know the opposite. We're looking for the adjacent and the hypotenuse. Okay. So if we know this is 90, lucky us, we can find my next angle it's 90 minus 58.39, which is going to be, let's see, 2161. So I'm not sure I said 1. 31.61. That's my x. How do I find the other two sides? Well, since we have the opposite, and let's see, what's opposite adjacent? Opposite adjacent is tangent. Tangent of 58.39 is equal to 13 over y. That's the setup, because we're looking for the opposite and the adjacent. So flip y is equal to 13 over tangent 53.39. Do the math, right? That's calculator work. Now, if you don't show this work, I know you're cheating. You had to set that up. Define the hypotenuse. That's opposite over hypotenuse. That's sine. Sine of 58.39 is equal to opposite over hypotenuse. Flip, z is equal to 13 over sine of 58.39. Okay, plug that in the calculator. That will give us our z value. Now I'm going to go through our other values, how to solve triangles. This is not a right triangle, so we're going to use either law of sines, law of cosines. If you take a look here, we do have an angle side pair. So which one is angle side pair? Law of sines, law of cosines, to remind yourself. Law of sines, okay? So we can set this up to solve for x. That's going to be sine of x. That's angle over side is equal to angle over side. Cross multiply, sine of x is equal to 31 sine of 21 over 23. Calculator work that. And then don't forget to undo sine inverse of your answer. Now if you look here, there's a video for these problems. If you get stuck, you forget, there's a video for these problems. Go and click the video if you forgot how to do these problems. And many of these questions do have videos, so you guys can double check with them. Now I'm going to do one more question if you guys have any other questions. Again, there's a video already on this on the website of all the problems worked out. Looking here, I don't have an angle side pair. No angle side pair, no angle side pair, no angle side pair. So we're going to use law of cosines. And the cosine here, let's call this a here. It's going to be a squared is equal to b squared plus c squared minus 2bc cosine of a. If you remember that formula. How do I remember it? Well, I remember if it's looking for a squared, it's the other two guys. And so it's 2 times the other two guys, cosine a. So a squared is equal to 14 squared plus 19 squared. Now, do you really have to memorize this for the final? Nope. You just have to make sure you write it down and are clear enough to yourself that, hey, I got to use this formula. But if you haven't practiced it, you will still fail because you need to know how to use these. Now, if I go ahead and take a square root of my answer, that's going to be my a value. Turns out that's going to be 8, surprisingly. They said round to nearest 10th also. So round to nearest 10th. Make sure you follow the rounding. Okay. So any other questions before I call it a day? Okay. So if you have any questions, go ahead and please email me or contact me with what question that you need help with, okay?